Hello everyone, and welcome to the first video of the project. In this tutorial we'll be looking at doing random scrolling hills. To start with, we're actually going to make static jagged peaks, and we'll evolve it until it turns into smooth scrolling hills. I've just got a brand new Flash file. I'm going to save it, so we'll save it in a suitable place. I've got a folder called Project 1, and I'll call this example so I can upload it for you to use later on if you get stuck. Hit save, maybe change this to a sky colour since we're going to be outdoors, and that's the Flash file ready. So we're going to start in our ActionScript file. File, new. If you're in CS5 or above, you can just choose ActionScript 3 class. If not, just make an AS file and catch up the few lines that you'll be missing. I'm going to call this one Scrolling Peaks, and eventually we'll extend it to be Scrolling Hills as well. Hit OK, and Flash will generate some code for us. We're just going to adapt it to what we want. So I'm going to import flash.display.sprite, and that's because our scrolling peaks are going to extend sprite. We're going to extend Flash's sprite class and put extra features to make our peaks. So make sure you've got extend sprite there. We will need some variables here, so let's just stick the comment vars, and then we've got the constructor, so that's okay. Let's save that as it is. Make sure it's saved in the same place as your example Flash file, which that wasn't, so let's try again. Desktop, Project 1, save. There we go. Okay, let's get started then. So we're going to need some variables for our peaks, and the first of which will be the total width, the span of these hills, the range. So we'll have a protected variable instead of private. If we want to extend a class later on, we have to use protected instead of private. So I have a protected var, we'll call it total width, and I'll make it of type number. I'm spacing these things out so they're easier for you to read later on. If you feel the need to comment lots of things as you go, just go for it. There's nothing wrong with comments. They're good, if anything. So let's just say the total width of the range. I won't be commenting everything because I'm talking as well, so you can do the commenting for my vocals, like I'm singing. Under that, we're going to have some public variables that the user can change from outside the class. So I'll have a public var, the first of which will be the minimum width of an individual peak or hill. So I'll have min width. That will be type number again. And I'm just going to copy that line and paste it 3 times. So we've got a min width, we'll have a max width, we'll have a min height, and we'll have a max height. Stick a comment here to say these are for individual peaks. Okay, and finally, we'll come and add more as we go. We'll need a protected var called points, and this will be an array that we'll use to hold all the points of our range as we go. So it'll be the peaks and troughs will be stored as points, and we'll link them up with either lines or curves later on. So that's the variables set up. Let's go to our constructor and just throw in some default values for these. So we'll say total width to start with will be 550, which is the default size of a Flash file across horizontally. Min width of a peak, let's say about 50 pixels. Max width of a peak, say 100. Min height of a peak, don't want them any smaller than 100, and max height can be 300. If I just hop to the FLA and show you what these numbers actually represent. So we've got the total width here, which is all the way across the file. We've got, well, it's more easy to represent it that way, total width that way. So we've got a bounding couple of lines there for the total width. I'm just going to make them a bit thicker so you can see. We've got a minimum height, let's say that's about here, so no hill will be any smaller than that. And then we've got a maximum height about here where no hill will be smaller, taller than that. So we've got hills that will be inside this rectangle basically. And the logic that we'll work on in a second is to pick a point somewhere along this, in this bounds of height, and then start drawing a line out until we've gone at least the minimum width of a peak. Anywhere between the minimum and maximum width, and we'll stop drawing. And then we'll click again, we'll draw another one that's again between the minimum and maximum width, but still within this bounding rectangle, and we'll just keep going like that randomly until we get across, which means we've done a whole range. And that's the logic we're looking at doing. This will eventually be filled in as well, so we'll have solid colour. It definitely won't be yellow because that's making me want to throw up straight away. Let's go back to the class and do the code for it. So we've set the default variables here. Let's put some placeholders for what we need to do. So we need to plot the actual hills. All this variable stuff, we need to do some logic. And we'll have a function for that. We'll make a function called plot hills. We need to draw them as well. So draw the hills. We'll call that draw hills. I'm doing them separately for a reason. We could just have one massive code, but eventually we're going to extend this class, and having them split up in this way makes it much easier to just pick the bit we want to replace. We're not going to replace every line, every word in this class. We're just going to be selective about it. And that will probably do for our constructor. Let's just check that it actually compiles by going to our example, coming along to the first keyframe, going to the actions and making an instance of it. So let's say var hills equals new scrolling peaks. There we go. Save that and test it and just make sure that it compiles. It doesn't, and that's because we don't have those two functions we just made, so that's okay. If they're the only errors, then we're on track. So we need to actually make these functions now. And we'll start with the plot hills. Just give myself some room at the bottom of the class so I can scroll down. And we'll start with a protected function, plot hills. So we're only going to use this within the class or within any classes that extend from it. So I'll have a protected function called plot hills. It's not going to take any information in, so it's just brackets and closed. It's not going to return anything, so we don't need anything there. Although you might want to remind yourself that it doesn't return anything by telling Flash that it's void, it doesn't return anything. I don't normally do that, so you might not have seen that in my videos before. In here, what we need to do is do exactly what I just drew out. So we're going to use a while loop to go across our screen, plotting points using these values as the bounding regions. So we'll set up a while loop. Just use the keyword while and then open your brackets. Oh, one problem. I just realised we didn't make a default for points. That would have caused errors. So points here in the constructor needs to be a new array. You could have used a vector if you like using vectors. I'm just going to stick to an array. It's what I've been showing you as we go. So while points.length, this is the amount of points in our array, while that is less than 2, you can't have a peak without at least 2 points. You need 2 points to connect to make a line. So while points is less than 2, or we're going to access the last point, points, then square brackets, points.length minus 1. That will give us the last element in that array because arrays start counting from 0. We count 1, 2, 3, 4, an array will count 0, 1, 2, 3. So we have to take 1 away from what we'd actually say. So if the x position of that last point is less than the total width of our hill range, we want to keep going. So this loop will keep happening until we've gone past our total width. Now we need to make a point, make a new point, which means we're going to have to import the point class as well. So let's say var p for point. We'll type point equals new point. We're going to have to give it an x and a y eventually. Let's see at the top, Flash has imported 0.4 as there. It's been very kind. If it hasn't for you, make sure you type that in. So we've made the point, and here we need to know if it's the first point. So if this is the first point, we'll treat it differently. So let's say if points.length equals 0. That would mean this is the first point. We're going to set its x to be 0, so p.x will be 0. If it's not the first point, we'll have an else. p.x is going to start at the position of the last point, so it'll be points.length minus 1 dot x. We're going to set it to be on that point, and then we could do this in one line, but I'm going to split it into two to make it clearer for you. We're going to do p.x plus equals, so I'm now going to add something to that. Let's just space everything out a little bit so you can see. Going to add something to it using our min and max width. So we're going to add to it at least the minimum width of a peak. So straight off the bat we're adding the minimum width. We're then going to add a random amount between the min and max width. So the difference between them we get by doing max width minus min width. And then we'll times that by math.random, which is a random number between 0 and 1. So we're effectively getting a random amount of the difference between the max and the min, and then adding that to the minimum. That keeps us within that bounding range we were talking about. Next step is to do the y, so we'll do p.y equals. This is very similar logic to this here, but as you'll probably know, Flash counts down the screen in the y direction. So up here we've got 0, 0. Down here we've got 0, 400. Now hills, in the real world and in our Flash file, count upwards. Altitude goes up. So, awesome arrow. We need to invert that number. So what we'll do is start with minus min height. So we're actually counting into negative space with our hills so that they go up. Then we're going to take the difference of the max height minus the min height times math.random. And that will count up the screen from the bottom. When we've got to make sure that we position the hills at the bottom of the screen, otherwise they'll just go off the top and it'll be totally pointless. The last step, and this is important because you'll have an infinite loop if you don't do it, we need to push the point into our list. So points.push p. Add the point to the range. At this point, let's just save it and test it again, just to see if we get any compiler errors other than the draw hills part. Maybe just comment out the draw hills and test that. Right, no errors. Obviously nothing happens. We haven't told it to draw anything yet, but we're not getting any warnings, any compiler errors, so we can assume we're okay. Let's uncomment draw hills. Let's collapse the plot hills, and we'll make this function, this draw hills function now. So I'm going to make, again, protected, so we can override it later on. Protected function draw hills. Doesn't take any information, doesn't return anything, so we'll put void. And in here we're going to go through each point and draw a line from the last point to the current one. We'll start by clearing the graphics. So we'll access the graphics of this sprite. That's why we're extending sprite, so we have access to this. And we'll do .clear, so get rid of the graphics. Wipe the graphics, and then we'll set a line style and a fill color. So set a line and fill style. Graphics dot line style. We need a thickness. I used 4 before, so we'll stick with that for now. We can change that with variables and so on later on. And a color. Let's stick with black. So we'll just go with O for black. No color. Graphics dot. And here we begin fill, which tells Flash what colours to use to fill the area between our lines. And I'm going to go for a sort of green, so let's find a decent green. something a bit like that one maybe, that one. 336600. We'll use that. So we'll go OX 336600, and that will be a green colour. Now we want to move to the first point, so let's just move to the first point. Graphics dot move to points, and to remember, as I said, an array starts at 0, so we'll have point 0 dot x, points y dot point o dot y. Sorry, that was totally wrong. So we've moved to that point, and from then on we're going to loop through the rest of them and draw lines to it. Loop through the remaining points and connect them with a line. So we'll have a for loop. For, open brackets, var, and I'm going to use I, short for integer, so we'll make it type integer, equals 0. 1, sorry, we've already done 0, so we're going to start our for loop at 1. I is less than points dot length, so we'll do every point in the list. And I++, so we want I to get bigger by 1 at the end of each iteration through the for loop. So as we do this for loop, I is going to get 1 bigger every time until it's too big. Dead simple in here. All we're going to do is graphics.line2, and we'll access that point. We'll do points I.x, points I.y. If we test it at this point, we should get something, but it won't be exactly what we're after. Let's just edit the example code so that we can actually see these hills. So we've made them. We need to position them. So we'll do hills.x equals 0, hills.y equals 400, so they're at the bottom of the screen. Just comment that in. And then add them to the screen so we can actually see them. Let's save that. Make sure I saved the class. Yes, and test the file. Now they're drawing over these lines, so let's get rid of them. Try it again. And you can see that we're getting something, but it's not quite what we want. It almost looks like origami. And that's because we're not completing the shape of the hills by connecting them back to the start. We're not going down and along the bottom to fill in the space. We're just going straight from the last point to the first point. So we need to connect back to the start. And we do that with 3 more lines, so we'll do graphics.line2, and we'll use the last point that was done, so that will actually be I-1, because I will have gone up by 1 to leave this loop. So we'll do line 2 points I-1 dot x, and we'll use the y position of 0, so we'll go back down to the bottom. The next line will be the first point in terms of x position, but still at 0 in the y. So points 0 dot x and 0 in the y. And finally we go back to the first point. Graphics.line2 points o dot x and points o dot y. And then we should end fill, really. We should do graphics.endFill. Save that. Let's try it again. And we can see that we get some random hills. If I hold Command or Control and press Enter, we see that they actually are random and they're staying within the bounds that we mentioned. Kind of interesting. We can get different effects by changing these variables. Just really quickly, I want to keep this section quite short. This will be the biggest section of the tutorial, but it's fairly lengthy. Let's change this. Let's say the minimum width of, let's make it smaller, 20. Max width of 50, so we've got shorter peaks. Save that and test it. We can see they're much more compact now. We could make them smaller, we can make them bigger here with the max height, put that down to 150, so they're shorter. And there we go, we've got sort of bumpy, distant mountains. They're still green, we could change that, and we will do later on. So we're set up, we're ready to go now, and I'll leave this section at that. I'll save the files as they are. For those of you just joining the video at this point, you can download the files in their current state and carry on with us. Okay, see you shortly. We're going to take a quick look at get and set functions now. They're very useful. They allow you to present something that seems to be a variable to a user, but it's actually a function and it can do a lot more than just set a value. For example, if we were outside of this class and we wanted to access the min width, we'd just type hills.minwidth equals and it would set that variable to be that number. However, if we use a get and a set function, we can do more than simply just set the value, and we're going to do that now. We'll add a couple of variables in a specific way. So we're going to add a protected variable for the hill colour, and we're going to lead it with an underscore, and I'll explain a bit more about that in a while. So I'll have a variable called hill colour. I am English, so I'm going to spell it that way. You'll just have to deal with it. And that's going to be a uint, an unsigned integer. Underneath it we'll have protected var called line colour. That's also a uint. And then let's see, what else do we need? We need a thickness for the line, so I'll have protected var line size. That will do. And that will just, we'll keep that as an int, should we? No, we'll go with a number. Okay. So we've got these three variables led by underscores. We could also have, we could do scrolling. Actually, we'll do that while we're here. Protected var scrolling. Make that a boolean, so we're either scrolling or we're not. And the scroll speed. Protected var scrolling speed, and that can be a number. So we've got the variables set up, and they've got an underscore because we're going to use their real names as function names, and you can't have a variable and a function that have the same name. So the convention is to lead with an underscore. You don't have to do it that way. They could be named something totally different and then have the function names with the real names. What we'll do is look at setting them up now. So I'm going to collapse some of this stuff after I've set defaults for these variables. So in the constructor, let's quickly set hill colour to be the green we used. Was it 336600? We'll do a line colour as solid black, so we'll just set that to O. Line size, we'll set that to 3. Scrolling as false, we don't want to scroll instantly. And scrolling speed we'll set, it won't be used obviously if we're not scrolling, but we'll set it to be 1 by default, so 1 pixel per frame as default. So they're all set up, and I'm going to collapse the constructor down just so we've got a bit of space. Collapse the plot hills. The draw hills will just update to use those variables. So the line style now is actually going to use line size and line colour. And the begin fill is going to use hill colour. Anything else there? It should be okay. Let's just check it works. Let's save and test. Seems to work. No errors. Okay. Run it again. Yep. Okay. So that's working. Let's just collapse that down. Now underneath everything else, I'm going to do all the get and set functions. So I'll do a big multi-line comment here just to lead us into it. Get and set functions here. Let's copy this line. And okay, so a get and a set function are treated as variables outside of the class, but they're anything but that inside the class. Let's start by making it public so we can get to it from outside. It's still a public function, but instead of going straight into the function name, we have either get or set. So let's say we're going to set the colour here. Let's say public function set, and here we'll put hill colour without the underscore. So this will seem to be the variable name from outside the class. because it's a set function, we need to pass in some information. So we'll give a colour here. We'll go C for colour, and it's a uint. It's not going to return anything, so it's void. And then in here, the first thing we do is set our real value, our real variable of hill colour, to match C. What's really good about this set function though is we can do more than just set the value without the user ever realising what's going on. So in this particular instance, we've set the colour. We also want to redraw the hills to use that colour, so we can just call draw hills again. That's something you couldn't have done just by directly setting this variable. Sure, you could have set the variable and then called draw hills from outside somewhere, but the user wouldn't think to do that. It's kind of the way the scale works on a movie clip. When you change the scale X property of a movie clip, it'll instantly stretch, and that's because it's working similar to this. Let's save the class at this point, skip out to our example file, and just check it's working by changing the colour. So let's do hills.hillColor, and let's make them blue. So OXOOOFF for a solid blue. Save that and test it. And we get blue hills instantly. You might think that, okay, just set the colour and they've been drawn because they've not appeared yet. So to just make it very clear what's going on, we'll add a quick event listener, stage.addEventListener. We'll make it a mouse event.click, and we'll call it update colour. Function update colour, responding to a mouse event. I'm just doing this really quickly, so I'm ignoring a lot of the convention. So we've got that, and now when we click, if we save that and test, it starts green, and when we click, it goes blue. So there's no doubt there that when we click, this is being set and it's being redrawn. Okay? So that's how the getSet works. They're really good. Learn to use them. We'll quickly do the get for this one. Dead simple. Public function get this time. Hill colour. Doesn't take any information, but it does return something this time, and it'll return a uint. And we'll just return hill colour. And they're both set up now. We could access the hill colour from outside by just putting hills.hillColor. We wouldn't need the underscore. It wouldn't work with the underscore anyway because it's a protected variable, which is why these underscore variables are often private or protected, or they should always be private or protected. And then the getSet functions are your public way to get to them. Which are the variables have we got? We've got the line colour. That would work the same way, so we could copy and paste these two. And let's just edit this to be line colour. Line colour. And again, we want to draw the hills when we update the line colour. Save that and test it's working by changing the example here. We'll set the hill colour and we'll do hills.lineColor as well. Set that to be, let's go white, just polar opposite of what it is by default. Test, when we click we should get blue hills with white line, and we do. So that's working. Okay, the important part, making our hills scroll. We want them to move. We haven't done the line size. You should understand how to do that now. I'll let you do that one. Scrolling and scroll speed. We'll start with the scrolling one. That's probably the most complicated. Needs to do the most. So down here, we'll do these above the existing ones. We'll do public function. We'll do a set, and we'll do scrolling. It's going to take in a Boolean value, so we'll go b Boolean. It's not going to return anything, so it's void. And we want to set scrolling to match b, so scrolling equals b. Underneath that, we can now check to see if we should be scrolling, we'll start the hill scrolling. If they shouldn't be scrolling, we'll stop them. And we'll do that with an event listener. So if scrolling, that's the same as writing if scrolling equals true. So we're just asking if we should be scrolling. And if we should be, we'll add an event listener. So we'll need to import event.enter frame, and we'll call it scroll. Maybe not, we'll call it scroll hills. So when we should be scrolling, we've added that event listener. It also means we'll have to quickly import that. So let's nip up to the top. Flash didn't import it for us this time. We'll import flash.events.event. Come back to our set function, and we'll have an else here. So if we shouldn't be scrolling, we'll remove this event listener. So copy that line, paste it back in, change add to remove. Save that, and we'll need the corresponding scroll hills function. So I'm going to do that up here above the get and set functions. This can be protected as well. There's no reason for people to get to this from outside. Public function scroll hills, responding to an event, so little e. And what we want to do is move the points. So we're going to move the points to the left based on the scrolling speed. Now, is it scroll speed? Scrolling speed, okay. So we're going to loop through all the points. So we'll have a for loop. For, and we'll go with var I, type integer, equals 0. I is less than points.length. Try to space everything out. Points.length. I plus plus, so I get one bigger every time. And we'll just move that point. So we'll do points I dot x plus equals scrolling speed. And that will move the point to the left. What we also need to do when we move them, we need to detect if they've gone so far that the second point in the list is now off the screen. We need to delete the first point because it means that peak is totally off screen, so it's no use to us anymore. It also stops the hills going to infinity, like just generating to the left forever. So we'll say if points1.x is less than 0, try and space these again. Just try to compact everything when I'm working alone. So if points1.x is less than 0, so bear in mind that's the second element in the list, we want to move or to delete the first point. So we could do points.splice. We could splice from index 0 and remove one element. That would work. Or we could just do point.shift. And shift takes the first element out of the list. It actually returns it as well, so if you wanted to use it, you could store that in a variable. And hopefully that logic's okay. What we do need to do though, after we've scrolled them, we need to plot them again. So we're going to plot hills and redraw them. So we'll draw hills. Just using the two functions that we've already got here. Let's check that that works by saving it, going to the example, and instead of changing the colour, let's just set them scrolling. So we'll do hills.scrolling equals true when we click. Let's cross our fingers and click, and whoa, they're going the wrong way, my fault. That should have been a minus, not a plus. If we're going to scroll to the left, we need to go negative in the x direction. And there we go. So the scrolling left, and if I just extend it a little bit so you can see what's going on. Points are being generated by our plot points function because it will generate them as long as it's below the total range length. And our scroll hills function is deleting them when they grow so big that they've gone off the other end. So we're staying within a certain limit outside of the bounds of the hill. We could correct that even further. If you don't want to be able to see what's going on outside, you can either mask your hills or you could use a scroll rect. So here when we make the hills, we could do hills.scrollRect equals new rectangle and then dictate the area of that rectangle. So this would have to, this is bearing in mind the position of the scroll of the hills, which is, they've been moved 400 pixels down, so the x would be 0, but the y position of this rectangle will have to be minus 400 to compensate. And then the size of it is the size of the hills, so in this case 550 by 400. Save that, test it again, and it breaks. Done something wrong. Okay, maybe it didn't need to be minus 400. Let's try 0. Didn't like that. Right, okay. Let's put that to minus 400 so the rectangle goes upwards. There we go, we got there in the end, third time lucky. And you can see now that the scroll rect we've made is clipping the hills to be the perfect size. So that's quite useful. If you don't want your hills to completely fill the screen and you're worried about them overlapping or just looking weird when they keep deleting, then use a scroll rect or a mask. That was a bit of an aside, wasn't really the point of this section of the tutorial. So there's the logic for the scrolling hills. We've done the set, let's just do the get as well. Public function get scrolling. Doesn't pass anything in, but it does return a boolean, and we just return scrolling. Okay. What else have we got? We've got the scrolling speed. This is an interesting one, so we'll do that one. We'll do the set. The set's normally the most important one because that's where you do your rules. Public function set scrolling speed. This is going to take a number, n for number. Doesn't return anything, so we'll have a void there. And in here we want to say that our underscore variable for scrolling speed equals n. But we want to limit it. If we have a scrolling speed that's positive, we're eventually going to break our flash file. Sorry, if it's negative, we're eventually going to break our flash file because we're going the wrong way and we're never deleting those points. Let's say if scrolling speed, we could have used n. If it's less than 0, set it to 0. And we can trace something out there. We could say, warning, you cannot have negative scrolling speeds. So another benefit of using a set function, instead of just making this variable public, we've managed to limit it. We can automatically limit our variables, much like the rotation setting of a movie clip does. You'll find it very difficult to set a rotation less than minus 180 or greater than 180. It's because it's rounded off. It's limited towards those. It's wrapped. That was the word I was going for. And let's just do the get for this one. Public function get scrolling speed. Doesn't take anything in, but it does return a number. And we just want to return scrolling speed. Let's just quickly check that by trying to assign a negative scrolling speed. So in our example, when we click, we'll do hills dot scrolling speed equals -10. Let's try and make them go -10 the wrong way. When we click, we'll get an error first of all, so something wrong there. Can't create property scrolling speed on scrolling peaks. Let's see. I've not saved the class, that's why. Make sure the class is saved. Try it again. Click, and there we go. We get the warning, and our scrolling speed's automatically set to 0, so they don't scroll. If we try and set it to +10 and click, we can scroll 10 pixels every frame, and that works fine. So that's working okay. And just before I wrap up this section, which other ones have we got? We've done the main ones. You can do the line size. I will do it before I upload the final file, but you can practice your get and set functions. I think for now that's okay. So I'll see you in the next section where we'll look at actually rounding off the hills instead of having jagged peaks. The next big step is to make the hills smooth, but just before we can do that, we're just going to tamper with the constructor in the scrolling peaks class before we extend it. We're going to give the user of this class the option to pass in some extra information when it's made to make the hills a bit more customized to their liking. So for each of these variables we've got here, we'll make a sort of a sister variable as an argument in the constructor. We'll also provide default values so that the user can decide to just not pass anything in and the class will still work. So we'll start with the top one. We'll just work down from total width. So we'll have t width as the sister variable for this one. That's going to be a number, and by default we'll have it as 550. Then we'll have a comma to go to the next one. I'm going to do a line break as well because this is going to get quite long. We'll have a min w, the width. We'll set the default of 20. I'm just going to pull the defaults from the list we've got. Max w, also a number, that'll be 50. Min h, number of 100. And a max h number, let's make that a bit bigger, let's go 200 by default. Keep going, what have we got? The hill colour, let's say hcol, that's a uint, and that can be the green, so 33660. And the line colour, lcol, by default black, it's a uint and it's 0. The line size, so L size, that will be, what was that number? 1 as default. Scrolling we'll set as false. How can we have that one? We'll have is scrolling. Boolean equals false. And what we'll have to do to make sure that the constructor actually triggers the scrolling when we set this, if the person does choose to have it true from the off, we want to use the set function instead of the actual variable. So I'm going to delete the underscore, and I'm going to do the same for the scroll speed. Probably a good idea to do it for some of the other ones, but we'll leave them as they are. So we've done the is scrolling, and we need to do the scroll speed. So we'll go scroll speed instead of scrolling speed. That's a number, and by default we'll set that as 1. I think that's everything. We don't need to do the points. What we do need to do though before that will work is make the constructor actually use these. So let's go down the line here, making it use those passed in variables or the defaults. Hcol, lcol, and lsize. Is scrolling, nearly there, and scroll speed. So the constructor now will use any values we pass in. Let's just save it at this point. Go to our example and try a few of them. Hopefully the code hints will appear. No, they don't. That's weird. I would have thought they would. Let's just make sure it knows what type to use and try it again. No, it's not having it. I definitely saved the class. Weird. Normally they would appear, so I'm guessing for you they will appear, but we know which order. Let's just try 300 as the total width. Save that and test it. And we can see that straight away our hills are 300 wide. Let's try altering some of the other things. Notice how all the other defaults have kicked in there. Let's affect the min width. Let's put that down to 2. Max width to 6. So we've got really small peaks. And we get really spiky small peaks. It's almost like vegetation, sprigs of grass and stuff. Can change the heights, make them smaller. Let's have 100 and 120. And it's, again, small and bumpy, so it's definitely working. Let's just put that 300 to stage.stage width. So it's just taking the stage width as default. I'm going to get rid of the rest and just work with defaults. So that works. Okay, and we're now in a position where we can extend this class and make scrolling hills instead of peaks. So let's go File, New. I'm going to make a new class or a new AS file, depending on which version you're in, and we'll call this Scrolling Hills. hit OK, and we're taken to a new AS file. This scrolling hills, make sure it's saved in the same place as scrolling peaks. So mine's desktop project 1, scrolling hills. OK. And public class scrolling hills is going to extend scrolling peaks this time. So we're actually extending the class we've made, and just to make sure that's working, I'm going to save it in its current state, go back to my example, and edit this code to instead of using scrolling peaks, I'm just going to delete that. I'm going to make it use scrolling hills and see if it works. And you can see that it does. So it's working. It's pulled in all the functions, all the variables, all the properties of the scrolling peaks class and adopted them as its own. So our scrolling hills mimics our scrolling peaks perfectly at the moment. We're going to change it. We're going to make it behave slightly differently. I've got a couple of examples of ways we're going to do this. I originally set out using these Bezier segments, or Bezier segments, I'm not quite sure how you pronounce it, it's probably French. And they plot curves out for you using 4 points here. So these are points A, B, C and D. And if I just test the file, you can see that we get a nice curve between the points. And by moving the control points here, these B and C, we get a slightly different curve. We can move A and D if we need to, and that will change the start and end of the curve. And that's how a Bezier curve is done. What I've also got is an example that doesn't use Bezier segments, Bezier curves. It just uses the curve2 property of the graphics class, which you can see it does the job there when it's at the sort of shape we're after, but moving around you can see in the middle where the two curves come undone, where they sort of don't quite merge very well. And that's because curves in Flash only have one control point. So if I draw a line and pull it, I can pull it up that way. Then if I go to another point on the line and drag, it doesn't turn into an S, it just turns the original control point. That's the problem I had with using curves. The advantage of curves is that they will scale perfectly. There's no loss if I zoom in. It's because they're drawn as vectors, whereas if I zoom in on the Bezier example, you should eventually see that these are actually just lines. Probably too detailed at the moment, but you're starting to see it there. If I put the detail down, I just change the code quickly, make the detail a bit less. You can see straight away that that's just a series of lines. So that's the downside there, is that the scalability is not quite as good. But I would argue that you're best using Bezier, particularly if you're going to do things like collision on these lines, because you can actually store each point along the curve, whereas the curve2 tool just draws the curve for you. You don't have a memory of where the points of that curve are. The deciding factor for me, though, was this. Woohoo! Tiny Wings. What a game. Go and buy it if you've never played it. But these little bits of decoration, if I was ever going to program them, I'd be using the points along a Bezier curve to find the position to start the decoration, but also the angle as well. I'd remember the angle between the 2 points and set the decoration out at that angle. So that's what tipped it for me and why I decided to use Bezier. I'll do it both ways in this tutorial, and you can make up your own mind. I'll also include these 2 test files if you want to go through them yourselves. Anyway, waffle over. Let's get back to the Scrolling Hills class. I'm going to import fl.motion.bezier segment so that we can make a Bezier curve. We probably have to import point again because we will use that. So flash.geom.point. Okay, save that. I'm going to leave the constructor for now. We will come back and do it. I'm just going to hop into the Scrolling Peaks class and find the draw function. So the draw hills function, I'm going to copy the whole thing. Come back to my Scrolling Hills and paste it underneath the constructor. Now this on its own would cause errors because we already have a draw hills function, but what we can do in this Scrolling Hills class, because it's based on the Scrolling Peaks class, we can override this function by typing override in front of it, and that will tell Flash that this particular class has its own version of this function. We want to change the way that function works. So the rest of the behaviour from the scrolling peaks class will remain unchanged, but this draw hills will be different. And in particular, I want to change this bit. Inside the for loop, we're not going to have a straight line connecting the points, we're going to use a Bezier segment. So I'm going to delete what's there, and I'm going to go about making these points. Look in the example, we've got A, B, C and D. Now A and D are already made for us, they're the points of our peaks. We need to calculate B and C, and they're not too difficult, so let's do them first. We'll make 2 points, we'll make var B, which is a point, capital P, equals new point. And the x position of this is going to be the halfway point of A and D. So it's going to be, in brackets again, points I minus 1, so we want the previous point. We start at 1, so we're not in danger of breaking the for loop. We're just going to take 1 off and go to 0. So we get the previous point's x position. We'll add the current point's x position, so points I dot x, and then we'll half that, so we get the point between the two. And that's where B will be. It's also where C will be. Then we'll have a comma and we'll put the y position. If we have a quick look, the y position of B is the same as A. So we'll just do points I minus 1 dot y as the y position for this point. Var C, very similar. It's going to be a new point also. It's going to have the same start, so the same x position. So let's copy that and paste it. And it's going to have the y position of points I. Quite simple, but there are intermediate control points. So they're made. Next step is to make the Bezier segment. So var Bezier of type Bezier segment equals new Bezier segment, and then we pass A, B, C and D. So we need to pass points I minus 1, B, C and points I. And that makes our Bezier segment. Now we want to draw the segment, so we're going to have a for loop underneath, and we're going to work systematically through this curve, connecting straight lines to various points along it. And to do that we need a variable to step through, so I'm going to make a var called step, and it's going to be a number, because the time value along the curve goes from 0 to 1, so an integer wouldn't be any use. So we'll make step a number, and we'll start at 0. We'll say as long as step is less than or equal to 1, we'll keep going, and then we need to increment step. We need to make it bigger in some way. You might hard code a number in here, so if you want 10 lines in your curve, you'd put 0.1. That would put 10 lines in. What you might choose to do is have a quality variable. So I'm going to put 1 divided by quality. I'm going to do quality with an underscore. It's gone blue, so I guess that already belongs to Flash. Let's have curve quality. Curve quality. So we'll use that variable. We'll have to make that, and I've done the underscore so we can have get and set properties for it. Get and set functions, and that's the for loop setup. Just quickly nip to the top and paste this variable in. So make a protected var curve quality, and it's going to be a number. In the constructor we'll just set it to 10 by default, so 10 lines in the curve, in each curve, and then we'll generate the curve. The first step is to actually get the point that is the current time along the curve. So we'll make a variable to hold it temporarily. Var pt is a point, and it's going to equal Bezier dot, and we want to get value, and we have to pass in the time here, so we're going to pass step in as our value for time. So that will be a number between 0 and 1. So we've got the point now, we know where to draw the line to. Next step is to draw the line. So we do graphics.line2, pt.x and pt.y. If I save this, come back to the example and try to test it, you'll see a problem. Notice that it hasn't worked, but if I click, it does. And that's to do with the constructor. In our scrolling hills, we haven't done the constructor, so it's using scrolling peaks constructor, which draws straight lines instead of curves. We could just ask it to redraw itself again. We could just put draw hills here and hope that that works. If we try that, and that works straight away. But what I also want to do is change this constructor so that we can pass information in just as we did with the scrolling peaks. So I'm going to come to the top of the scrolling peaks. I've already got it selected. I'm going to pick all the arguments, copy them, go back to the scrolling hills class and paste them in. So the scrolling hills takes the same arguments. I just want to change the defaults though. So I'm going to make the hills wider. We'll say at least 100 wide and no bigger than 200. And just before we're done, we're going to use the super keyword. So we're going to type super and then open brackets, and this accesses the scrolling peaks constructor. So we want to still set up the same way as the scrolling peaks. We're just going to redraw the hills here. So we're going to pass all this information in to the super constructor, which is basically just this. Because scrolling hills is a subclass of scrolling peaks. Scrolling peaks is a superclass, scrolling hills is a subclass. They're also known as parent and child, or scrolling hills is often known as a derived class. Waffling again, let's pass all these in. So t-width, min w, max w, min h, max h, h-call, l-call, l-size, is scrolling, and scroll speed. And that will do all our variables for us. The parent class will set them all. We'll set the curve quality and we'll draw the hills. Save that, test it, and we can see that it works and we get some nice long stretched hills which look pretty good. Might want them slightly taller possibly, but I'm going to leave that to you. Oh yeah, I was going to do curves, wasn't I? So in the final version of the class, I'm actually going to keep this. I'll finish everything off, or do all the get sets and so on and upload it finished, but I will be using the Bezier part, not the curves. I'm just going to comment it out for now and show you how to do the curves if you so choose. So just underneath all that, we'll just draw two curves using these points that we've already generated. So we're going to do graphics.curve2, and the curve2 function takes the control point and the anchor point. Now the control point is the B or the C, and the anchor point is where the curve finishes. This first curve is going to finish halfway between the start and end point. So I'm going to put in brackets points I minus 1 dot x plus points I dot x. Oh no, sorry, that's wrong. I want this is the control point, not the anchor point, so I want halfway between the point A and B. So I'm going to have A, we've already got there, and B, and then divide that by 2. This is just random numbers that I've played around with to get the right sort of effect, so feel free to manipulate them a bit. And the control point is going to be at b.y. The anchor point is in the middle of A and D. So that again takes B's x position, b.x, and the middle position of B and C. It's the easiest way to do this, so b.y plus c.y over 2. And the last curve, graphics.curve2, this is from the midpoint to D. So it's from between B and C all the way to D. And the control point is just C, I think. No, it's not. It's halfway between C and D. So we'll do c.x plus points I.x, divide by 2, and do c.y. So that's the control point, the C of this curve. And then finally, point D. So points I dot x, I've missed an S, and points I dot y. Save that, try it, hopefully it works. Yeah, so it looks pretty much identical. If we keep an eye out, you might see some sharp sections that don't quite look right, but at this sort of range and speed, you're really not going to notice it. They're never going to be the main feature of your game, these hills. People would be looking at the characters. So you can probably get away with that. I don't like it though. I'm going to get rid. I want to stick to my busier stuff. If you're wondering how I would have gone about storing the locations, for each of these steps I would have pushed the point values into an array and then used them to generate the sort of decoration that we mentioned. So I'd store these points in an array and just randomly generate bits of graphics to poke out from them. So that's why I'd stick with this. I might still do it for the project that I let you have a go at. But for now, I'm going to save this class and I'll polish it off, upload the final version, and I'm going to do another video having you present something you've made using this class. I want to see what you can do. I've shown you enough for now, so you're going to impress me with something hilly. I'll see you soon.